Okay, so now we're going to look at two examples. You roll a number cube. A number cube is basically a dice. And if you guys already know this, a dice has the numbers 1 through 6 on it. Event A is you're going to roll an even number. Event B is rolling a prime number. And so we're going to calculate each one of these up here. We're going to find the probability of A, probability of A union B, probability of A intersection B, and the probability of A complement. So, the first one, we're going to start with A. The set. We need to figure out what kind of set we're dealing with. Once again, we're rolling a number cube. So the set is going to be everything that we are dealing with. So we know that we're going to deal with the numbers 1, 2, 3, 4, 5, and 6. That is all the numbers that we can possibly deal with. Now, then we have the A set. Our A set is, once again, event A is rolling an even number. So I'm going to look at my overall set, and I'm going to find all of the even numbers. So I've got 2, 4, and 6. So those are going to be all of my even numbers within my set. Then, what we're going to do is we're going to figure out the number in each of these pieces. So the number in the set is, well, 1, 2, 3, 4, 5, 6. So I have 6 elements in my set. Then the number in my A set is going to be 1, 2, 3. So I'm going to have 3 elements in my A set. So then all I have to do is plug it into my equation. So my equation is the probability of finding A is going to be the number in my A set divided by the number in my overall set. So the number of elements in my A set is 3, and the number of elements in my overall set is 6. So my overall probability, the probability of rolling an even number, if I were to simplify this fraction right here, 3 goes into both of those, so I'm left with 1 over 2. So my overall probability of rolling an even number is 50% of the time, 1/2 of the time. Half the time I'm going to roll an even number, half the time I'm not. Part B is wanting you to find the probability of A union B. So we're going to put A and B together. It's going to be both A and B in the part that it intersects. And so we need to write down the subsets. So we know that A is 2, 4, and 6 because A were even numbers. Event B is rolling a prime number. So I'm going to come up here just for a moment and look at my entire set. And looking at that, my prime numbers are going to be 1, 2, 3, and 5. Those are all going to be prime numbers. So then we're going to calculate what the probability of having these sets. So the subset for B, rolling prime numbers, is 1, 2, 3, and 5. So now I'm going to think about what is going to be the number of elements that I have with A union B. So I'm going to look over here. I've got 3 for A and 1, 2, 3, 4 for B. But I've got to also be careful because in both A and B, they're sharing a number. They're sharing a 2. And so in my mind, I'm going to kind of scratch out one of those 2. So I can do that. I'll show you guys obviously with this. But I'm going to scratch out one of those 2s because with a union, you can't repeat numbers. And so now what I'm going to do is I'm going to look and see, okay, I have 3 for A and 1, 2, 3 for B. So the number of elements that I have for A union B is 1, 2, 3, 4, 5, 6. So I have 6 elements for A union B. Finally, we're going to find the probability. So I'm going to use my equation. The probability of A union B is going to be the number of elements in A union B divided by the number of elements in the total set. So the number of elements in A union B is 6. And the number in the total sets is going to be this number up here, 1, 2, 3, 4, 5, 6. So I have 6 elements. So 6 divided by 6, which, if I were to simplify that, is basically 1. So what this all means is that the union, if I were to roll an even number, or if I were to roll a prime number, the chances of me getting that is every single time. In other words, 100% of the time, I'm either going to roll something in the A set or something in the B set. I'm going to let you try C on your own. Sorry, I made a mistake there. So next one is C. We're going to find the probability of A and intersecting B. So I'm going to use the same set. A is 2, 4, 6. B is 1, 2, 3, 5. Now the intersection is going to be the number of times that I repeat a number from A to B. So for instance, I'm going to take my pen here, and I am going to circle the number of pairs that I have between A and B. So 2 is in both of those. And honestly, that's the only number that's in both of those. So I have one pair that is going to be the same in A and B. So that's what it means by intersecting, is that they have a same number within those. And so the number of elements that are in A intersection B is 1. So what I'm going to do is I'm going to use my equation, and probability is going to be the same as the number of elements in A intersection B divided by the number of elements in the set. So the number of elements in A intersection B is 1, and the number of elements in the set is 6. So we're going to have 1 divided by 6. So in other words, in 1/6 of the time, we're going to be rolling a 2, basically. Then part D. This time we want to know what the probability of that AC thing, the complement. And so this is how we're going to do that. So I'm going to use what the complement is everything that is not A. So I'm going to use this information up here to help me. In my entire set, I have 6 elements. And in my A, I have 3 elements. So in order to figure out what I don't have, I have 2, 4, and 6. Everything that's not part of A is going to be, for instance, 1, 3, and 5. So I have 3 elements that are not part of the A set. So that's going to be the number of elements that I have. So it's going to be 1, 3, and 5, or in other words, the number of those elements is going to be, here I'll do this, A to the C is going to be 3 elements. So my equation then is going to be the number of elements of my complement divided by the number in my set. So 3 in my complement divided by the number in my set, which is 6. Simplify that to be 1/2.